Hi there, welcome back to my channel. Today I will be covering the Canny edge detector. And so with the Canny is actually a filter and it's a multi-stage edge detector. It uses a filter based on derivative of a Gaussian in order to compute the intensities of the gradient. And so in this particular images, I'm showing you an example of what I'll be demonstrating in this particular tutorial. And so here we'll have this first image that contains noise and this object that has some edges, and we could see this by the gradient. And so with Canny, we will be using the Canny to be able to detect just the edges, and then we'll throw away information about the middle and maybe preserve the outside. And so we're just interested in just the edges. For example, this is a square and we're just interested in this. Then one way of like getting this is using the Canny edge detector. And so by the time you apply with sigma 1, then you have this, which is a bit still noise here. And by the time you go to 3, then you have a more smoother object. I mean, in this case, this looks more like this compared to the edges. They look more similar compared to this one. But yeah, the more the sigma, then the smoother your curve becomes. Okay. And so let's code how to use the Canny in this particular tutorial. So clear this up. These are the packages we need. We need a NumPy. We need Matplotlib for the plotting. We need a scikit to generate the image, the object that we'll be using to do the Canny upon. And we need this scikit utils random noise to add the noise to this particular image that we generate here, or the object we generate here. And then we need the Canny, which is in the future of scikit. And so first we have to create that object. So we have to generate a synthetic image with a square, as I showed you earlier. And so I'll just say image. I'll just say image, which is the image that I'll be giving it. I will just create a zeros with a NumPy of size say 128 by 128. So this is like an image, but it's filled with 0. We give it a data type. Sorry, I can type data type of say float. I just call them float, and that's it. I think I need that one as well. Okay, so now we have the image. Like we could even plot that to take a look at it first. Let me just plot that really quick. And so if we do plt.figure, and if we do plt.imshow, that will be all zeros of image. This is how it looks. It's all zeros. Could even add a color bar just to make sure that everything will be 0. Okay, it's all zeros. Could give it a gray so that we could even like see the most obvious way. So it shows as black basically. So cmap is gray, and then those are all zeros. Okay, let's continue. Let's manipulate this image. Let's add an object in the middle, and this is how you add object to the middle. So we just pick the image that we generated, and inside of this image, say starting from pixel 32 to say the last 32 in the y, and then we'll do the same thing in the x 32, so all the way to the last 32 in the x. We'll force in the value of 1. Remember we created here as zeros. Now we're giving these particular ones as 1, so this is a square that will contain 1. And so if I run this now, this image will change to having a box in the middle. So that's the box that we created now. These values here are 1s, and we could even check that by doing a color bar. So if we do plt.color bar, then we could see that the white are 1s and zeros are this. Okay, and so now we have our object created. Now next we want to add noise onto this, but before then let's even make the task even more challenging by adding some rotation to this. And so in this particular image, or we could even like apply some sort of smoothing and then do the rotation, so that it's not, the edges are like not so easy to detect. So to do that we just need our image. Let me just pick the image. I will write the information on it, and I will do a Gaussian. Yeah, I have to import, if I want to do it that way, then I have to import one more stuff, and that would be from scikit. From scikit, the Gaussian is in the futures. I already have futures, so maybe I should just do it this way. If I do futures dot Gaussian, I should be able to get something. I haven't tried that before, but it's good. We'll learn together here. Dot Gaussian. Hopefully, it did not autocomplete. And in the Gaussian, I'll pass in the image and I'll give it the sigma, which is how much the standard deviation or the noise, the width of the noise, the width of the deviation, the width of the Gaussian distribution. And so the sigma will give it to be 1. So that's how much is deviating, and this will be make it smoother. Remember, it's close to the mean. The farther away, the more noisy it will look. And so we just want to make the edges smooth. So if I run this code now, it complained that I couldn't find the Gaussian in the future. Oh, I see. The Gaussian is actually in different place, so we'll have to do scikit.futures. Scikit.futures, not futures. Futures. Import Gaussian. Import the Gaussian. Okay. And then we could remove this. It's not in the futures, it's in the futures. Oh, it's getting interesting. Gaussian, that's correct, from futures. That's interesting. So we couldn't find futures in Gaussian. I thought they were, it worked. Maybe I had a typo. That was crazy. And so now we see that the edges are now a bit smooth compared to the way we had it before. Next task is to rotate this actually. And so to rotate it, I already have the code in the previous tutorial I did, and so I'll just copy and paste it here since I wasted some time there. And so we're just going to OpenCV and using the wrapper file, passing in the image that we just smooth here, and then giving the rotation that we want to apply to it. In this case, we're giving it just a 15-degree rotation. We can make it 25-degree rotation, and that's the image. Okay, now if we run this now, this box has rotated by that much, by that amount of degree. You could play with this value and see how it will change. Next step is to add noise. I will just paste the line to add noise here since I already have it. It's basically I'm creating a noisy image from my particular image, and I'm using the random noise that we imported here from the scikit utils, and I'm using the mode to be sparkled, and the mean of the noise is just 0.1, so it is a small noise. So if I run that, there are noise in this, it hurts to see, but yeah, there are some noise in it. What if we increase this to 0.5? Yeah, it's hard to see, but there are noise. So now I've added noise to that. Next is to apply the main stuff in this tutorial, which is the Canny detection. Again, I'll copy the line of code from where I have it and paste it and explain to you what it is doing. And so to apply the Canny, we just need to use the Canny, which we already have had it imported in this part of these futures. And so we'll do the Canny and we'll pass in this noisy image, and then we'll tell it the sigma. So we're now just like doing two different edges to just show you how this will change. So if we give you sigma 1 compared to sigma 3, this one will give you the standard edges of this particular box, so it will look more similar, as I said at the beginning of the tutorial, but the 3 will give you a more smoother edge. And so we'll run these two, and then we'll do a subplot this time to check how it looks like. Okay, and so let's do that by pasting a subplot in this next line and then running it. So Here I'm just plotting the the noisy image as a grayscale, and that's the noisy image, the title, and I'm plotting the edge 1 and edge 2. We're just interested in the edge, we're not interested in the white region or the black region, just the edges of this particular stuff that we're interested in. And so to do that, and this is also good for like if you have drawings or pictures that you just want to like use to like trend something, then maybe you're just interested in the edges to maybe measure how big or stuff how it is, then you could just do something like that. So if I run this now, I'll have a tree plot. This is the noisy image that I've been showing you above, and this is how the Canny will remove the edge of this object when you're using the Sigma 1 and Sigma 3. So that's how to use the Canny in Python. Let me know in the comment if you have any issue making it work on your computer. Also suggest any video you want me to make. Thanks. See you in the next tutorial. Bye.